Oopsie daisy. Alright, oops. Let's turn the sound down. Don't want that beeping every time. Alright, and now we're just about ready. We're going to do an indirect proof, first of all, as a review for this test. It's on page 354, so if you look at page... Let me change some things here so I can draw on this. So it's page 354, and it says number 5, but it's not like regular number 5, it's above it. You see where it says check your progress? Okay, so there you go. And let's draw the thing first. Looks about like that. Looks about like that, and that. And this comes down about right there. And this is M, O, N, and P. Alright, and let's see what they give us. So we're going to do this as an indirect proof. MO equals ON. Alright, so those line segments equal. And then, and this is kind of like an indication of when you would use an indirect proof. When it tells you something that is not equal to something else. Alright, that's a real big light bulb should come off, okay, when you see, go on, I guess, when you see this. Because you're like, we say, oh, something's not equal to it, that's probably when we go indirect. And especially if we're trying to prove something that is not equal. You can use an indirect proof to prove other things, but it's really helpful when you have to prove something that is not equal to something else. So we want to prove that that is not equal to this angle right here. Okay? Let's take a look at it. Let's mark our picture first. MO equals ON. So we mark that, we mark that. And then MP is not equal to NP. So let's use a different color just to do this. MP, which is this one, it's not equal to NP. So let's like make, I don't know which one's bigger. We'll do like that. How's that? You want a squiggle? That's actually a good idea. I never thought of it that. Squiggle? Squiggle. That's my squiggle. Alright, good enough. Alright, is that alright? So what is that? What does the squiggle mean?
Not equal.
This is Caitlin's law. The squiggle means what? That they're not equal to each other. Okay. Okay. So we want to prove that the angles MOP. Where's MOP? This angle right here. So squiggle angle and squiggle angle. That looks kind of nice.
That is not a my gosh.
It doesn't. It kind of straightens it out when I draw on this program. It kind of straightens it out. So we want to show. Shh, let's stop all the comments and listen, please. Thank you. So we want to show that this angle is not equal to this angle. So what do? We assume, don't we? We assume that angle MOP, what? Is equal to angle NOP. Because remember, we always assume the opposite. Okay, that's our assumption. It's a P. It's just, I said P's. Oh my goodness, you guys are killing me. Alright. Alright, so angle MOP is, wow. Wow, the last letter of my first name has an N in it, so there you go. And the next to last letter of my first name has an O in it. Woo! Alright. Okay, here we go. So let's assume this is true. So if this was true, let's go back here and get rid of all this junk. I don't like this. Sorry, Caitlin, but that's a little. Your law didn't last very long, did it? Okay, so here we go. Assume that the angles are equal to each other. So assume that this is equal to this. That's what we're assuming, right? Okay, so I mark it up here just so we can see. Now, again, what are we trying to do? We're trying to show that angle MOP, I'm sorry, and remember, this doesn't, let's do it like this. Let's say see they're different sizes, so we'll say they are not, we could do that. That's a good idea. Why didn't I just do that? There you go. So that's got 2, that's got 3, that means they're not equal to each other. Alright? So now, let's see what we can do here. Assume that these are equal, so you've got a side, you've got an angle. Anything else strike your fancy here? Yeah, so I tell you what, we'll do this in white so that we keep all the equal stuff together. Okay, so we'll just do 2, but it's in white, so it's different than that one. Is that all right?
How do we do
So
that?
so look at this. So now what do we have? We have what? Side angle side. Would you agree? So assume that's true. We can also say that you could. I'm just writing it out in paragraph form. You don't even have to say we know, but you could just say that what OP, line segment OP equals what? Line segment OP by what? Reflexive property. Reflexive property. All right, so we know that's true. And so what must be true then? So triangle MOP would be what? Congruent to triangle NOP. Would you agree with that? If those two angles are equal, okay, by what? What's my reason? Side angle side. So these triangles would be congruent, right? So that means if these triangles are congruent, I'll put another so in there. So what? MP must be what? Equal to NP. By what reason? Yeah, CPCTC. That's right. But what's the problem? This is a contradiction, okay? That's a contradiction. So we say, we can put, but this contradicts, but this contradicts, can't spell, contradicts, well, we have to say it, but this we have to say what it contradicts. What does it contradicts? It contradicts the given, right, that says what? That MP is not equal to NP, right? So we showed our contradiction. This contradicts the given, so what we assumed is what? We say false. So what we assumed is false. Therefore,
MOP.
right, angle MOP is equal to angle NOP. That's not that big of a deal. Come on. So assume that they're equal to each other because you always assume the opposite, okay? And then you just see what else you can figure out here, right? In this particular problem, now not every indirect proof do you have to show that triangles are congruent, and stuff like that. But in this one, it worked out pretty nice, didn't it? Because we saw a side and a side. We saw this angle. We said, hey, wait a minute. They're congruent triangles. What do we care about congruent triangles? Well, the corresponding parts have got to be equal to each other. That means this and this are equal to each other. But hang on a minute. We can't, oops, sorry. We can't have them equal to each other, can we? Because the given says that they're not equal to each other. So that's a contradiction. They can't be equal and not equal at the same time, can they? That contradicts the given, all right here. So what we assumed is false, right? So this assumption then is a false assumption. If it's a false assumption, then this original thing that we wanted to prove must be true. And that's what we showed right there. All right? That's not so bad, is it? Therefore. This means contradiction. This means therefore.
So, angle.
All right. So what we showed that MP and NP are not equal to each other, right? Right, because it contradicts. They would be equal to each other, but that contradicts this, right? So there's our contradiction. Even if we have one contradiction, our assumption then must be what? It must be false, right?
No, I'm just saying at the end, you put that MOP.
Yeah,
MOP
therefore.
equals,
Yeah, because look, this was our assumption.
but then you just.
Oh, I'm sorry.
Oh,
I forgot
okay.
that. That was my bad. Okay, I forgot that. I'm completely sorry about that. I meant to put not equal.
That's what I
Therefore,
was
they don't
confused about.
equal. Thanks. So, right, I assumed that they were equal, found a contradiction, so then my assumption is wrong, so I got to go the opposite of my assumption then, right? Which is what I wanted to try to prove in the first place. Yes. Yes. Study guide number 15.
Yeah, I didn't
378, number 15. Okay. Due to time, I might not go through the whole thing, but I'll get you started on it, okay? Okay, the number 15 with the ordered pair, that is a little bit lengthy, so I didn't put that on the test because I think it takes a little too long. So the ones with the ordered pairs, I did not put that on the test. But let me just, since this is review, let me just kind of tell you really what you need to concentrate on. You need to concentrate on these words: the circumcenter, okay, the incenter, and the centroid. Those three right there. That's what you need to focus on because that's what's going to be on the test. All right. So 337. Remember, I said that earlier. I said look at page 337. So page 337, they list all three of those on there. I'm going to collect them tomorrow. Those papers, those homeworks, both those homeworks will be due tomorrow, okay? I always let you hang on to them so you can study for the...
Are these the only ones we need to know on the test? The circumcenter, incenter?
Yes.
That's it.
I think there was only one more anyway, wasn't there?
Yeah, there's just Porthos Center.
Porthos Center, yeah.
And we don't even know.
Okay, let's take a look at this real quick. Okay, let's go through a real fast little explanation of these just to remind you. It's on page, listen, shh. It's on page 337, but I'm going to go through this again. The circumcenter. How do we find, first of all, the circumcenter? What's it say? Anybody want to look at page 337? Perpendicular bisector. So what do? You look for, now I'm just going to sketch this really quick.
Why is there?
What's going on?
I don't know. Why is it now?
I don't know either. I'm confused.
Yeah, we have like 15 minutes left.
Shh, Timmy, don't. So what do? We find, right, the perpendicular bisector. So that kind of looks like it right there. That kind of looks like it right there, and then hopefully it'll hit about right there. Okay. So no, don't wait. Okay, I gotta move on. Okay, I'm explaining. So listen to my explanation the first time. I'm finding the perpendicular bisector of all three sides. So that's perpendicular, that's a bisector. Okay, this is perpendicular, so this segment right here is equal to this segment right here. Alright, this is perpendicular, so this segment right here is equal to this segment right here. Now, what's true about this point though? This point, and this is the important part that you understand, that point is equidistant from the vertices. So the orange lines that I drew right there are all the same distance. Okay? How did we get that point? We got it by the perpendicular bisector. But what's true about that point? That point is equidistant from the three vertices. So that question you had earlier about the baseball players. Okay, if you want to find out what point on that triangle are they the same distance apart, you would find the circumcenter. So that's circumcenter right there. Does that make sense? All right, let's do incenter. Incenter is a little different. Oh, if I can grab it, there we go. Make it a little bit bigger so I can draw in it. So let's talk about the incenter. Let's go with the same color coordination here. So how do we find the incenter? What do we do with that? Bisect the angle. That's right. Okay, so we look at this angle and we bisect the angle. That doesn't mean we necessarily go to the midpoint of the opposite side, does it? Okay, no, that would be the median. But this is bisecting the angle. So I'm looking at that angle. I'm trying to bisect the angle, and it looks something like that. All right, bisect this angle probably around there somewhere. See, I'm making these two angles equal to each other. And if I bisect this angle, hopefully it'll hit that point right there. And how did I do that? I bisected the angles, right? Those two angles were equal, these two are equal, and these two are equal down here. So what point did I just find right here? What point is that? That's the incenter, okay? Now, what's true about the incenter? If I went from here, where?
Down.
Perpendicular, okay, it's equidistant from the sides of the triangle. From the sides. This was equidistant from the vertices. This is equidistant from the sides. How do I find the distance to the sides? I go what? Perpendicular. That looks kind of perpendicular there already, doesn't it? Okay. All right. And so those three right there are all equal to each other. Same thing with this. Those three were equal to each other. That's the what? in-center. I wish we had a cute little way so you can remember which one is which, and I still haven't come up with a good way to show why that they're equal to each other, but you just remember it. Okay, circumcenter is this one, in-center is this one, and then centroid. What was the centroid? Okay, and what is that? It was the median, right? It was the median. It cuts the sides in half, right? Okay. Well, you go from, no, you don't necessarily divide the angle in half, okay? The median, remember, you're going down the road. Where are you? You're in the middle of the road, right? Median, yes? We had a big story about that, okay? So what do? I go from the vertex. Now, I'm not necessarily bisecting this angle. What am I looking for? I'm looking to bisect the opposite side. Looks close enough. Then look at the other side. See, I'm looking at this side right here. I'm trying to find the midpoint of the opposite side. Probably around in here somewhere. Okay, and then that would be it right there. They're concurrent, right? Now, what's true about this one? You remember? From the vertex to the, what do we call this thing? Centroid. This is twice the short one, right? Or it's 2/3 of the whole thing, right? So if this was 10, what's this little bitty part right here? That's 5. Make sense? Okay. Same thing for the other ones, okay? Remember, from the vertex to the centroid is the longer one. From the centroid to the opposite side, to the midpoint of that side right there, is the shorter one. So the longer one is twice as big as the shorter one. So that's what's true about the centroid. Is that ringing a bell?
Yeah.
Good. Okay. And that's good we went over that, because it's been a while since we've done it, and it does get a little confusing. I have to remember that myself. So again, if I was studying for this test, I would study that myself. And you have quite a few problems that deal with that. All right. So you might have to answer like 2-3 questions on each one of these. Everybody understand that? So I'd really study that stuff. Okay. All right. I'm just going to scan through the test real quick here, and kind of let you know what to expect so you know where to concentrate your studying. Okay, so 1, 2, and 3 is about the in-center. All right, we talked about that. That would be this one right here. All right, oops, not a very good circle, but you get the idea. And then 4 and 5 deal with the circumcenter. That's the first one we did.
Numbers 4 through 5.
4 and 5. And then 6, 7, and 8 deal with the centroid. And you know what? I lied earlier. I didn't really lie because I didn't notice it. But I do give you one problem where you have to do the ordered pair thing. Okay, and I'll tell you this. I'll tell you that it's a centroid problem.
Wait, the ordered pair?
Yeah.
What's that?
Remember I said I didn't think I put it on there, but I must have just not saw it when I was looking.
What number?
Okay, that's number 9 on the test. Okay, so number 9 on the test, it's a centroid. Well, you would just mark it. So how do you find the centroid? You find the midpoint of the opposite side, right? So I would graph it out, right? Graph your 3 points, make a triangle out of it. And how do I find this side right here? Find the midpoint. So use the midpoint formula, right? Yeah, to find that, right? Find that. So that's how you find the centroid. Right, that's how you find the centroid, is just by doing this. And I'll probably put a graph on your answer sheet so it'll help you out a little bit.
What was
Okay,
6
so
through
you
8?
could graph it and it'll help you out.
What was 6 through 8?
So that was number 9.
Number 10.
Okay, we got to move on. Running out of time. Numbers 10 and 11, where it just says list the angles and sides from order from smallest to largest. So 10 and 11 list the angles and the sides of the triangle from smallest to largest. You did that several times on the review sheets. One's the angles. One's the smallest angle to the biggest angle. One's the smallest side to the biggest side. Okay. 12 and 13 is really easy. They're 2 problems where you have to state the assumption on an indirect proof, right? So you just assume the opposite. That's easy. So that's 12 and 13, where you're just stating the assumptions on an indirect proof. Number 14 is an actual indirect proof. And this is an actual, it's easier than the one we did earlier, the one we did with the congruent triangles. You don't even have to go congruent triangle on this. It's actually very simple, okay? All right? So, but just write the stuff out. Write the word assume. Show the contradiction. Show that it contradicts, your assumption, and then show that, what you're trying to prove. If you have those basic things in there, you shouldn't have a problem with that. All right, 15 and 16 is where I give you 3 sides, and you have to determine, does that make a triangle or not. So how do you determine if those 3 sides make a triangle? Yeah, add up the 2 smaller ones, and it has to be what? Bigger than the 3rd side. If it's not, then it's not, okay? And I just said, is it possible? So I don't even ask for an explanation there. So just yes or no. You get 50-50 on that. That was 15 and 16. For number 17, what do you think is after that one? What do we do on the problems? The range, right. I'll give you 2 sides, and what is the range of your possible 3rd side? Okay? Yeah, you just add and subtract and put them in between. Yep, put the smaller one on the left and put the bigger one on the right. It's very simple once you understand what to do. Okay, and 18, 19, and 20 are where you compare 2 triangles to each other and you see which angle is bigger, which one is smaller. Remember that? So,
So you don't do that like
so
right inequality?
well, this would be an inequality. So 18 and 19, you do write an inequality. And an inequality, you just say, like I'll give you A, B, and C, D, right? And I'll give you the picture, and you just say AB is less than, or AB is greater than, or AB is equal to. It could be, I don't know. Okay.
Yeah, right.
So there's only 2 questions.
Here's the quiz.
That would be like, which one's she
It's not going
saying?
to be like these.
No.
Okay.
I didn't put that on there, did I? I should.
You did it?
Right. Like 8, 9, 10 on the quiz is not going to be on the test.
Because I got the one wrong.
All right. There you go. That's it. Good luck with that.